Hello everyone. Today let us discuss about the lathe machine and its operations. So basically, lathe is a machine tool which is used to perform the various operations to give to the desired shape and size. So basically, the material is removed in the form of chips to give it to the desired shape and size by using these lathe machine. So let us have a discussion on the lathe machine tool. So in the mechanical engineering field, lathe machine play an important role in manufacturing. Lathe is one of the most versatile and widely used machine tool all over the world in the metalworking industry. It is commonly known as mother of all other machine tools. So because the various types of operations, the lathe operations which can be performed by using the different attachments, so that is the reason why this is called as a versatile machine tool or the mother of all other machine tools. So the main function of this lathe machine tool is to remove the material from the workpiece in the form of a chips to give it to the desired shape and size, and of course including the surface finish. So as far as the working principle of the lathe machine is concerned, so here the workpiece or the job is held between the two centers or held in the 3-jaw chuck or a 4-jaw chuck if the length of the workpiece is smaller. Suppose if the length of the work is relatively longer, in such cases the workpiece has been held between the live center and the dead center in the lathe machine, and by giving an appropriate cutting speed or rotation of the workpiece, the material is will be removing in the form of chips by feeding the tool against the rotating workpiece. So this the schematic diagram which shows the workpiece which has been held between the centers, that is the live center and the dead center at the head stock, and towards the on the other side is the tail stock. So the tool movement, the arrow mark which indicates the tool movement is been given against the rotating workpiece to remove the material in the form of chips, of course to give it to the desired shape and size including the surface finish. So this is what the schematic diagram representing the working principle of the lathe machine. Besides the simple turning operation in a lathe machine, the other various types of or the kinds of operations which can also be done by using this lathe machine, such as facing operation, plane turning operation, taper turning operation, knurling, thread cutting, drilling, reaming, boring, even including grinding. These operations also can be performed by using this lathe machine, of course by having the different attachments. The suitable attachments have been used in the lathe machine to perform all these kinds of operations. As already told you that is the reason why these machine tools are often referred as versatile machines or the mother of all machine tools. There are different types of lathes we have. So among them, these are the different types of the lathe machines. Right from the speed lathe machine, central lathe or engine lathe machine, turret and capstan lathe machine, tool room lathe machines, bench lathe machine, automatic lathe machines, special purpose machines, and CNC machines. Right. So the speed lathe are generally the smaller capacity lathe machines for simple jobs and with the minimum operations. These for such kind of things, the speed machines have been recommended. So higher depth of cut and higher this one it cannot be recommended for these speed lathes because the later jobs are recommended for these speed lathes. So similarly, engine lathe, turret lathe, tool room lathe. So these are the different types of lathe which can be used for specific purposes, and we have presently, and in the advanced as the advanced technology, we have the computer numerically controlled lathe machines. All these operations can be done automatically, right from loading the job or the workpiece and unloading after finishing all the operations. We can find in case of a computer numerically controlled lathe machines. So let us have a look the lathe machines with the various main parts of these lathe machine tool. So this is what the diagram of a engine lathe. So here you can see the various parts, the main parts of the lathe machine. the headstock, the tailstock, the tool post, the chuck, and this is what the carriage which moves along the guideways parallel to the lathe axis. This is the lead screw which is used for engaging the lead screw for during the thread cutting operation, and of course the feed shaft, feed rod is also provided here. So the various controlling mechanisms and speed controls is provided in the headstock. By operating these levers, you can control the cutting speed of the workpiece. So these controlling mechanisms, the power supply to the headstock we have. This is the diagram of the lathe machine with various parts which we are showing here. The another one also the lathe machine you can see with various parts have been mentioned here apart from the main parts. As already told you, the spindle speed selectors levers have been provided here. The driving clutch is also here in the headstock assembly, and the geared and pulley system you can see here, and these are the two legs which are supported for the whole lathe machine, and these are made out of a cast iron. By using a casting technique, these legs have been manufactured, so they have a better absorption vibration absorbing capacity and good wear resistance, etc. That is the reason why these cast irons have been chosen, and these have been produced by casting process. So this is as far as the parts is concerned, this is the carriage which moves the traversing direction, or the what you call the longitudinal direction perpendicular to the lathe axis, and this is the saddle, this is the compound rest, and this is the tool post where the tool is held here, and which moves the what you call the cross slide, the moves perpendicular to the lathe axis or the lathe axis. So by having these motions, utilizing all these motions of these carriage as well as the tool post and even compound rest for tilting the tool to certain angle with respect to the lathe axis. These features have been will be utilized to generate the required profile onto the workpiece to finally to get the desired shape and size. So these are all some of the parts we were generally observing in the lathe machine. The specification of the lathe is also another important thing. To generally, the specification of lathe means the distance between the centers, the live center and the dead center, and what is the maximum diameter of the workpiece that can be swing without touching the lathe bed, and what is the maximum diameter, what is the maximum height of the dead center and the live center from the lathe bed, and the maximum length of the guideways. These are all some of the specifications we need to have to specify the lathe machine. So you can see here the distance between the centers and the maximum swing diameter of the workpiece over the lathe bed, and the maximum swing diameter of the workpiece over the gap of the bed. That is another one. So this is with bed and this is the gap of the bed. How much the maximum diameter which can able to accommodate here during the lathe operation, and of course the overall length of the bed is also another one we need to have as under the specification of the lathe, right? These are all some of the things we need to identify, we need to know about the specification of the lathe. So let us have these things. So as I told you that the distance between the centers, that is the maximum length of the job that can be accommodated between the live center and dead center. Maximum swing diameter, as I told you, the maximum diameter of the workpiece that can be able to revolve without touching the guideways, right? And the height of these centers from the lathe bed, that is another one. Height measured from the lathe bed to the lathe axis, the length of the bed, overall length of the bed, and the floors, floor space occupied, right? And the range of speeds. So these are all the as far as the specification of the lathe is concerned. So, right. Now the various operations which can be performed, as I already told you, because the lathe is a versatile machine, because in the many number of operations like the facing operation, plane turning operation, among them the rough turning and finish turning operation, the contour turning, that means forming, profile turning and parting, the chamfering, thread cutting, including drilling, boring, and the grinding. These operations also which can be done by using the lathe machine by having a special attachments for these particular operations, and including of course knurling. So these are all the various types of operations which can be done, which can be performed by using the lathe machine. So let us go for the first operation, what exactly the facing operation. So here the two ends of the workpieces have been machined to have a flat surface perpendicular to the lathe axis. So let us have the pictorial view of the facing operation. So here you are observing the check, this is the workpiece and this is the tool. So this tool is advances against the workpiece and advances perpendicular to the lathe axis, where during the machining process and the ends of the workpieces have been machined to have a perfectly flat surface, perpendicular to the lathe axis or the axis centers. So as I told you that this is the operation of machining the ends of the workpiece to produce the flat surface with respect to the lathe axis, and it involves feeding the tool. So feeding the tool means feeding the tool perpendicular to the axis of rotation of the workpiece. So during the facing operation, this is the movement of the tool where the two ends of the workpieces gets flattened or flat surface you can obtain, and of course this is perpendicular to the lathe axis. So this is what the facing operation. And similarly, the another operation that can be done by using the lathe machine is plane turning. So here in the plane turning also the workpiece has been held held rigidly in the what you call the check, right? The self-centering check or the three-jaw check, and the cutting parameters like the cutting speed, feed, and depth of cut has been appropriately chosen during plane turning operation. Here the diameter of the workpiece get reduced during the plane turning operation. The cutting speed, the feed which you are giving for every the complete one movement of the tool, the feed, and the depth of cut in each and every step which you are going to give the depth of cut, all these have been given properly and carefully to generate the machined surface during the plane turning operation. Again in the plane turning operation we can find the rough turning operation as well as the finish turning operation. Again the appropriate single point cutting tool has been chosen to go for plane turning operation, right? So here you can see the diagrams of the schematic and as well as the three-dimensional view of the diagram you are observing here for the plane turning operation. So as I already told you, this operation is performed for producing the cylindrical surfaces by removing the excess material from the workpiece. Here the cutting tool is held in the tool post and fed into the rotating workpiece parallel to the lathe axis. So thereby what will happen, the diameter of the workpiece get reduced, and of course the material is removed in the form of the chips. And here as I told you, the cutting parameters have been carefully given to generate the machine surface or to generate a new surface where the diameter of the workpiece get reduced in a plane turning operation. So similarly, the other operation called as a step turning, where the different diameters you can observe in the machined surface of the workpiece. So here these are the diagrams we can observe here, where the shoulders between the two steps you can observe here the different diameters during the machining process or the during turning process you can have. In case of a step turning process, in step turning it is also called as a shoulder turning. When the workpiece of the different diameters are turned, the surface formed from one diameter to the other is called the shoulder. So this is called as a step turning operation or the process in lathe machine. The another one is a knurling. This knurling operation is generally doing for gripping purposes of the workpieces with a required narration or a profile generating on the workpieces. This is what knurling operation you can see here. The knurling tool which is used here particularly to generate this kind of a profile or narrations for gripping purposes for the devices or the workpieces. Okay, now knurling is basically the operation performed on a lathe to generate serrated surfaces. As I told you, serrated surfaces on the workpiece. This is used to produce rough surface For the gripping purposes, you can now generally we are observing in micrometer and even screw gauges of the barrel portion where the serrated surfaces is only for the gripping purposes. These kind of operations are done by using a lathe machine. So this is done by a special tool called Nerling tool. So this is the tool which we are using for knurling operation is generally called as a Nerling tool, which has a set of hardened rollers with the desired serrations, right?
Let us know how to conduct the facing operation by using the machine tool. Okay. Now the workpiece has been fixed here. This is a 3-jaw check, and so there are two types of checks. You can find one is the 3-jaw check, another one is the 4-jaw check. This is headstock, and this is the tailstock. This is the dead center. This is carriage. This is a lead screw. This is the guideways. This is the tool post and tool holder. This is used. This lever is used for cross-thread movement, whereas this one is lever which is used for longitudinal movement of the carriage. And these are the two legs. The whole thing is supported by the two legs which are made of cast iron by casting manufacturing process. So now, as I told you, that the workpiece has been held rigidly in the headstock by using the check key. This has been tightened the workpiece here. So after rigidly fixing the workpiece here, so the lever which has been operated to move the tool towards the workpiece, and the tool has been advanced against the rotating workpiece for the face. So now let us fix the workpiece by using the 3-jaw check here. So this has been tightened properly to fix the workpiece, clamp the workpiece rigidly. So now move the carriage towards the workpiece. Let us go for facing operation first. So now the tool is advances towards the workpiece. So now we are leveling the tip of the cutting tool. Now the tool is advances. Now the facing operation has been carried out. This facing operation, the tool is removing at the end of the workpiece. So the flat surface is obtained on one side of the workpiece, similarly on the other side also we can perform the facing operation to give the flat surfaces on either side of the workpiece. So workpiece rigidly on the chuck, 3-jaw chuck. So now the workpiece is already fixed in the 3-jaw chuck. Now let us start the machine now. Now the tool is advances against the rotating workpiece. The material is removing in the form of chips, and the cutting tool is moving towards the headstock and gradually removing the workpiece from the chips, removing the workpiece from the material is removing from the workpiece. Now the diameter of the workpiece is also reducing. So now we are observing the plate cutting operation is performing by using this lathe. So here the cutting parameters like the RPM of the workpiece, that is the cutting speed of the workpiece, depth of cut and feed has to be given appropriately. Okay. Now let us go for by giving another depth of predefined depth of cut. Now we will go for the second round of turning operation. So here after giving the specified depth of cut, the tool is moving held against the rotating workpiece, and the gradual feed is also given the cutting tool. So thereby the material is removing from the piece. And also you are observing the diameter of the workpiece is reduced here in the plane cutting.